Hi folks, welcome back to Math with Captain Rod. I'm making this video here to provide examples of solving equations containing fractions. So we're going to look at a couple different examples here. We're going to look at this guy, which is number 6 on page 124 in your college physics or college algebra text. And we're going to look at this guy, which is number 18 on page 124. I think the first thing I'll do is move this over a little bit to the left. All right. So we'll start with this guy. Now there's a couple different approaches we can do here. Approach number 1, and I'll just write maybe the first line, might look something like this. 20 over 2x minus 3. If we move this 4 to the left, this is going to read minus 4 equals 0. And what we could do is we could then find a common denominator here. The common denominator would be 2x minus 4. We could write this with a common denominator and combine these and start solving it. Now that's just one approach I wanted to point out. I'm going to take a slightly different approach here that tends to be a little shorter. I'm going to use what I typically call the fraction killing approach here. So what we have is we've got this equation here. It's got this fraction. And what you need to recognize is that if I multiply the left-hand side of this animal here, by the quantity 2x minus 3, it will divide out with this, and the fraction will effectively be gone. Now, if you're going to do one side, you have to do the other. So what I'm going to do is I'm going to multiply both sides of this fraction by the quantity 2x minus 3. I'm sorry, what I meant to say is I'm going to multiply both sides of the equation by the quantity 2x minus 3, recognizing that multiplying by that quantity will get rid of this fraction on the left. So on the left-hand side, these will now cancel. And the resulting line, 20 equals 4 times the quantity 2x minus 3. And you notice no fractions anymore. That's why I call it the fraction killing method. I'm not sure what it's called in other texts or what other instructors call it, but okay, next line. This 4, well, there's a couple choices here. We could either distribute it or we can divide both sides by 4. Noting that 20 is divisible by 4, I think I'll go ahead and divide both sides by 4. 20 over 4 is 5. Over here, these just reduce, equals 2x minus 3. Next step, add 3 to both sides. And if I do that, we'll have 8 on the left-hand side equals 2x, because minus 3 and plus 3 add to 0. Next step is to divide both sides by 2. And on the right, they reduce, and on the left, we have 4, and we're done. Now, I say we're done. We're not 100% quite done. Remember that the original problem had this fraction, and it's got an x in the bottom. Whenever you solve an equation like this, you always have to go back and make sure that this is an acceptable value of x. If we look back to the original problem, which was this, if x were equal to 3/2, you'd end up with a 0 down here, and division by 0 is not allowed. So x equals 3/2 is not a valid solution to this problem. So had this came out to x equals 3/2, we'd have to throw it away. It didn't. X equals 4. You know, if I put a 4 in the bottom, 4 minus 3 is 1, so there's no problem there. So the point of that last part is always be sure and check your answer and make sure it doesn't yield a division by 0 in the original problem. If it does, you have to throw the answer out. So we're good. X equals 4 looks like the solution of our original problem. Take a look at this animal. Oh, so here we have an equation, and it's got a couple different fractions here. We've got a fraction on the left, fraction on the right. Notice if I multiplied both sides by x plus 12, the fraction on the left would be gone. So I'm going to go ahead and do this. And this time I think I'll put this in parentheses here. All right, I'm going to multiply x plus 12, both sides, this side and this side. And notice that multiplying the right-hand side by x plus 4 would get rid of the fraction on the right. So I'm going to go ahead and multiply by x plus 4. Now again, I've used slightly different notation. Over on the left, what I did is I put a 2x minus 3 on the right and a 2x minus 3 on the left. Here what I've done is I've put a single x plus 12, but you'll notice I put the entire equation in parentheses. So this x plus 12 is going to be multiplied to both of them. That's equivalent to just putting this on both sides. So we need an x plus 12 to get rid of this, or turn that into a non-fraction, we need an x plus 4 to get rid of the fractions on the right-hand side. So when we go ahead and do the multiplication, and again, we're taking this entire quantity times the left-hand side. And I'm going to go ahead and write it all out. We're going to have x times x plus 12 times x plus 4 over x plus 12. Okay, equals. Now, when we take this quantity and multiply by the second part here, we're going to have 2 times x plus 12 times x plus 4 over x plus 4. All right, so we've done our multiplication. Now we're going to take advantage of the fruits of that multiplication. You'll notice on the left-hand side, these now cancel. So we're left with x times x plus 4 equals. Right-hand side, these now cancel. So we're left with 2 times x plus 12. All right, so what we've accomplished here is we took our original equation that had fractions. Now we've got an equation that has no fractions. Now, you'll notice that when you distribute this, we now have a quadratic. And that's fine. I'll go ahead and distribute on the right as well. 2x plus 24. Standard method for solving a quadratic is you want 0 on one side, everything else on the other. So I'm going to go ahead and subtract 2x from both sides. So let's see, now we've got x squared plus 2x equals. These are going to add to 0. And then we're just left with the plus 24. We'll go ahead and subtract 24 from both sides. We're now left with x squared plus 2x minus 24 equals, and 24 minus 24 is 0. Now I'm going to go ahead and take this. Need a little room here, just move it over to here. Keep working. Now, how these are solved from this point forward, there's a couple different ways. There's factoring, there's completing the square, and there's the quadratic formula. I'm a big fan of the quadratic formula. I teach physics, and most of the time in physics, the equations don't factor very nicely, so the quadratic formula I find to be a very reliable method. I'm going to go ahead and take a shot at factoring this. So this 24 here, notice that factors of 24, well, 24 and 1, 6 and 4 are both factors, and notice there's a 2x here, so I believe we can probably factor this into, how about x plus 6 times x minus 4. Double check, make sure it's correct. X squared minus 4x plus 6x, right? There's our plus 2x, so we're good there. Minus 24 equals 0, so there's the correct factorization. Right now, we're going to make use of the fact that we have two numbers, 1, 2, and the product of those two numbers is 0. That means that at least one of these is 0. So one possibility is maybe x plus 6 equals 0. Solving this for x, we get x equals minus 6. There's one of the solutions. Other possibility, perhaps x minus 4 is equal to 0. Solving this for x, we would get x equals 4. So, quick check, we got to make sure that these are not, would not yield a 0 in the bottom, so look back at the original problem. You'll notice to get a 0 here, we'd need a negative 12, so negative 12 cannot be an allowed solution. There's no negative 12s in sight, so we're good there. Here, x equals negative 4 would put a 0 in the bottom, so x equals negative 4 is not a solution we could allow. And I look over here, this is plus 4. So there's no problem with that. If I put a plus 4 here, that becomes an 8. So these are both allowed solutions. And we have two of them, and that's perfectly fine. A lot of times, you know, when you have equations that end up being quadratic, the possibilities are sometimes they have no solutions, sometimes they have one solution, sometimes they have two solutions. And what we found is two valid solutions. So again, the purpose of this video is to demonstrate how to solve equations that have fractions in them. I hope that this was effective in helping you learn how to do that. Have a great day.